Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to the Minamata online session on Mercury in Southern Hemisphere. And I think I will share my screen to for a introductory uh, uh, s- state words. But before doing that, I will share my screen, share content. So before going into the uh, content, I like to give you a bit of housekeeping note. Um, so um, uh, the one important thing is that we are going to use the chat function to collect uh, the quick questions that we will pick up in the Q&A session. So please use the chat box, and we may have time for our questions, and in that case, we will invite you to raise hands. But in our experience, we spend much time uh, the responding to questions in the chat box, and also question and the discussion among panelists. And please kindly note that this session is recorded and broadcasted, and a recording of this session and the presentation slides will be made available through the Minamata online website after the session. So, and with this, I'm going to change to my introductory slides. So this Minamata online session is entitled Mercury in Southern Hemisphere. Before going into the substance, I'd like to introduce you to the Minamata online series, which started in 2020. The Minamata Online is a series of online sessions on in three streams. The first one is the preparation for the conference of the parties that will be held in October this year. And then the second stream is about the implementation and review and support of the convention. And the third stream is Mercury Science. And we have agreed with the uh, uh, International Conference on Mercury as a Global Pollutant, ICMGP, to fully cooperate on the delivery of this Mercury science stream. And we are currently we are working on the synthesis papers that were developed in the process of the ICMGP 2022 that was held online last year. And I learned that the link to the synthesis papers from the ICMGP was already live this morning, and which is available free from a scientific journal Ambio. And this slide will be included in the slide deck, and you will see uh, the direct link to these papers. There are four uh, uh, topics. The first one is the general introduction, and second one was about the ASGM, artisanal small-scale gold mining, and the second one was about human health risk, and the third one is about the Mercury in Southern Hemisphere, part one natural process and part two anthropogenic perturbations, which are the topics of today's session. And the fourth one being the global change effects on biochemical mercury cycling. And we are going to convene a session on the 7th of June on this topic. So back to the slide, we have invited the authors of this synthesis paper, Jenny Fisher, Maria Diegues, Larissa Schneider, Lynn Martin, and Rob Mason. So with this, I think we have Lynn Will. I cannot see the list of participants while presenting sharing screen. Lynn will? Yes, Lynn will. So perhaps you can share your screen and give some words about as ICMGP chair. Lynn will, you are mute. You're still on mute.
Okay, thanks, Isaku. Just like to just get my content ready. Okay, are you able to see my screen now?
No.
Not yet. No.
Not yet. Okay. Yes, now?
Yes, Yes, I see the PowerPoint screen. I think it's okay.
Okay, so it's a slide of Cape Town that you're seeing, eh?
We're seeing the talk for later.
Okay. Sorry about that. I'll just get that sorted out. Okay. Okay, now you're supposed to see the right one.
Yes, I see.
Okay. Okay. So good morning, evening, afternoon, everybody. Greetings from Cape Town. I'm happy that we are again partnering with the Minamata Secretariat on this Minamata online series as part of the ICMGB initiative in leading up to the conference next year. Just to just send out a friendly reminder or save the date is that the 16th International Conference on Mercury as a Global Pollutant will be held in Cape Town from the 21st till the 26th of July 2024. And the theme that we will be running with for that week will be from Minamata to Africa and beyond, addressing Mercury challenges in a global environmental change. I hope we had some good support during the virtual conference last year. And I think it will be next year, it will be 5 years after the meeting that we had in Krakow in 2019. That was the last time that we had a face-to-face conference. So I do hope that everybody will register and submit abstracts to attend the 16th edition in Cape Town. We are currently busy, updating the website. We have appointed a new professional conference organizer that will organize the conference for us. So just be on the lookout. Say from early May, you will definitely be getting some emails from us in terms of just reminding you that you need to save the date to attend the conference. So I do hope that everybody will be able to come and experience the first ICGMP conference on the African continent, and only the second time it will be held in the Southern Hemisphere. Thanks, Isaku.
Thank you, Linville. So I think this is it as an introduction, and I will hand over to. I think Larissa, you're going to start, right?
Yeah. Sharing my screen. I'm waiting it to connect here. Can you see my slide?
Yes, I'm seeing your PowerPoint screen.
Yep.
With the menu bars and so on.
So good to go then?
We're still seeing just your notes and stuff, not the full screen version.
Notes. But I'm putting in presentation mode. That's weird. No, let me try again.
Yes. Ah, no.
Entire screen. Let me see if I share like this, it doesn't show the slide, right? Can you see the slide?
No, you're sharing the other.
Yeah, I know. But when I tried this slide before, it doesn't share the whole thing for some reason. Let me just try again. Sorry about that.
I can share slide if you wish, if it's quicker.
Oh, no, I'll try again. Can you see it now?
Yes, the PowerPoint
But
screen
not.
with notes.
Yeah, can you try to share from your end then,
Okay,
please?
okay. No worries.
Thank you.
Do that. So.
Okay, cool. Thank you, Isako. Good day, everyone. I'll start with a good day because I'm not sure what time of the day is where everyone is. In Australia, it's nighttime. So, my name is Larissa Schneider. I'm an associate professor at Australian National University. And I'd like to start this presentation today by thanking Dr. Celia Chen for helping us in putting this work together. She has really supported us, and this was a great effort between all these researchers listed here who are working in the Southern Hemisphere. So we are very glad to be able today to present the final product of this 2-year work. Next slide, please. Okay, so in the last 20 years, we have had a significant advancement of Mercury science. However, this advancement has happened mainly in the Northern Hemisphere environments, leaving behind a significant gap in knowledge in the Southern Hemisphere. So this is of particular concern because in this recent advancement in science, we got to know that the atmospheric lifetime of Mercury is actually shorter than first thought. So that means that Mercury is actually an hemispherical pollutant. And therefore, if we are to elaborate effective policies and regulation to control mercury pollution, we have to understand the mercury cycle at a hemispherical level. Next slide, please. Okay, so the scope of our synthesis paper was to review as many papers as possible that have been published in the Southern Hemisphere, mid-latitude and tropical regions. We decided to exclude Antarctica because it has unique environments and a unique cycle of mercury. And so therefore it warrants an exclusive synthesis paper due to this very different and unique cycle that is in there. So from this massive review that we have done, we came up with key differences of the Mercury cycle between the southern and northern hemisphere. And because of the broad geographic area that we were covering, we had to separate our work into papers. So the first paper is on the natural processes that affect Mercury biogeochemical cycle in the southern hemisphere. And the second paper is on the anthropogenic processes that affect the Mercury cycle in the southern hemisphere. And in these papers, we highlight the gaps in knowledge that we still have in the southern hemisphere, and then provide future research guidance for the next studies to come. Next, please. All right, so Maria, Diegues, and I will be talking about the first paper, which is about the natural processes affecting Mercury in the southern hemisphere. I'd like to note here that this paper is free to be downloaded at the MBO website, which is right there. Yes, and then Maria and I will be presenting the first paper, which is this one. Next. Okay, first difference that we have between southern and northern hemisphere in terms of Mercury cycle is that the southern hemisphere has more heterogeneous biomes with high biodiversity, which results then in higher Mercury variations in soils. Next. So from the data set that we reviewed, we realized that the background mercury concentration in soils of the southern hemisphere was very variable. I want to note here that our definition of background concentrations in soils means that we studied soils collected at sites that had no direct anthropogenic source of mercury. Most studies in the southern hemisphere and tropics, from what we realized during our study, focus on contaminated sites. So they are driven by ASGM coal-fired power stations, and very few of these papers actually have an understanding of the natural cycle of mercury in soils, and which is very important because we need to know what is the background concentration and dynamics of mercury in soils to be able to then compare modern pollution against and understand how much we deviated from what used to be natural. Next. So this is a representation of the data that we compiled on mercury in soils in the southern hemisphere. As you can see, there are quite high concentrations in South America compared to other continents of the southern hemisphere. Reason for that is because there are quite a lot of volcanic activities in that side of the world, which emits mercury and then ends up being deposited in soils. And also because of the rainforest, which uptake a lot of mercury or significant amount of mercury from the atmosphere and transfers it to the surrounding soil. For Africa and Southeast Asia, we found very little information. So the lines that you see in Africa are predictions of what we believe might be the concentrations based on the type of soil that exists there. As you can see, there's only like a few studies in the center, mainly. But we believe that the African continent might be similar to the Australian continent in relation to mercury, which is quite low compared to South America, for example. And the reason for that is that both Australia and Africa are quite old continents. And although Australia is quite arid at the moment, it has been quite wet in the past, and it had a long history of weathering. So all that weathering has washed the mercury from the soil, and because the desert doesn't have organic matter, it doesn't have a good binding agent to keep the mercury in the soil. So that's why we have these results quite low for Australia. And so we need more research to be done in Africa to see if what we would find over there. Next, please. So our second difference is that in the southern hemisphere, we have more broadleaf tree species, more evergreen vegetation, which then results in higher mercury uptake by vegetation. Next. So the global leader for mercury deposition has been modeled by Wang et al. 2016, and they produced this beautiful image that shows the uptake rate of mercury by vegetation. And it's very clear there that the hot colors are in the tropics, indicating that most of the mercury uptake by vegetation happens in this part of the world. So 70% of the mercury uptaking by vegetation is predicted to be happening in the tropics, and 30% to be happening in temperate and boreal areas. And this mercury uptake by tropical forests is in fact is believed to be responsible for the absence of seasonal mercury variation in the southern hemisphere atmosphere. So in the northern hemisphere, the concentrations of mercury varies along the year in the atmosphere, while in the southern hemisphere it maintains quite consistent, and this consistent concentration is believed to be maintained by the uptake of mercury by vegetation. And this high efficiency of tropical forests to uptake mercury is because they have evergreen broadleaf species, which has a large index area and longer leaf lifespan. So therefore, the efficiency to get the mercury from the atmosphere and deposit it in the soils in the local environment is quite high. And there's also a great contribution of epiphytes from these evergreen forests, which is believed to be contributing around 12% of this total mercury uptake by vegetation. Next. Okay, so third difference, which is very clear from that first picture that I put in the presentation, we have a much larger ocean area in the southern hemisphere, and therefore we have a larger source of mercury from the ocean. So more mercury being emitted from the ocean to the atmosphere in this side of the world. Next. So the ocean area, the total ocean area in the southern hemisphere corresponds to 81% of the total ocean area in the world. And in the northern hemisphere, it corresponds to 6% of the total ocean area in the world. And because there is higher anthropogenic emissions of mercury in the northern hemisphere, so the atmosphere there has higher concentrations of mercury, there is more mercury emission from the ocean to the atmosphere happening in the southern hemisphere compared to the northern hemisphere. And quite interestingly, we have a few observation data measuring mercury exchange between ocean and air, done from ship campaign. So, like everyone some people go to the ship and start measuring mercury concentrations there. And they, from their findings, they found that the oceans in the southern hemisphere are actually a net source of mercury. So that mercury is actually being emitted to the atmosphere. And there are some modeling predictions that have been published that says the opposite, that the net sink, that the Southern Ocean is actually a net sink. So it's actually mercury from the atmosphere is depositing into the ocean. So it's the other way around. So the observations say one thing, the modeling says another thing. So the only way to resolve this is by measuring more mercury exchange between ocean and atmosphere. And in fact, Rob Mason, who is going to be one of the presenters in this work here today, he has just come back from one of these ship campaigns, and we hope that he will have good data to clarify this. Next. And the export of mercury to the oceans from rivers happens 2/3 in the northern hemisphere and 1/3 in the southern hemisphere. being that the tropics is the area where most of the mercury, both total and methyl mercury, is being released to the ocean. So it's believed that 8% of the total mercury in the world that's being delivered from rivers to the ocean is being delivered in the tropics, in this tropical region. So it's just as uptake by vegetation, riverine inputs is also quite an important fact happening in the tropics. So now I'll hand over to Maria, who is gonna finish presenting our first paper.
Can you hear me?
Yep.
Yep. Okay. Other topic reviewed in the Mercury cycle comparing hemispheres is the methylation process. Next, please. Sorry. Our review on mercury methylation process highlighted the scarcity of methyl mercury data in the South Hemisphere, particularly in temperate ecosystems. Methyl mercury production has been mostly studied in tropical aquatic systems of Amazonia in South America. So it is possible to compare methylation processes between the tropics and temperate systems of the North Hemisphere. Next, please. Regarding the hotspots of mercury methylation in tropical systems, they have been identified in tropical wetlands of Amazonia, which undergo a large, within large floating meadows that develop from floating and submerged macrophytes, while in temperate systems of the North Hemisphere, hotspots occur in wetlands and lakes with well-developed macrophyte stands and periphyton communities and in lake sediments. In tropical systems, methylation rates are high year-round and peak during the flooding season. In contrast, in temperate systems of the North Hemisphere, methyl mercury rates peak in spring and summer. There are different variables that make that favor methyl mercury production in the tropics. In the tropics, the high temperatures year-round, the large flood pulses, and the decomposition of organic matter by anaerobic microbes create environmental conditions very favorable for mercury methylation. Next, please. Methylation is controlled by several physicochemical and biological factors, and thus is a ecosystem-specific process. These environmental factors can have synergistic or antagonistic effects on methylation rates, and given the high diversity of biomes in the Southern Hemisphere, and in order to get a better understanding of methylation processes, we need more studies in equatorial regions of Africa and Southeast Asia, as well as in temperate and arid systems of Southern Africa, South America, and Australia. Next, please. Our last focal point of the Mercury cycle in the Southern Hemisphere is related with the importance of geogenic sources. Next, please. Geogenic mercury sources are extensive in the South Hemisphere, and their contribution is more important than anthropogenic sources compared to the North Hemisphere. Geogenic sources comprise active tectonic margins, volcanism, geothermal activity, and at a lesser extent, mineral deposits. However, mercury data on emissions from different geogenic sources is restricted due to the sparse geographic coverage of mercury measurements and monitoring in the South Hemisphere. Next, please. Well, this figure shows the global distribution of geogenic sources, which are very important in the South Hemisphere. Main volcanic areas are located in the Ring of Fire, Circum-Pacific Ring, with extremely high active zones in South America, Indonesia, Papua New Guinea, Tonga, and New Zealand. There are also active volcanoes in the African continent belonging to the East African Rift system, to the Cameroon volcanic line, and also to the Indian Ocean islands. There are some in Australia and New Zealand. However, they have low recoverable mineral mercury. Next, please. For example, available data on atmospheric mercury in South America indicate the influence of mercury emissions from active volcanoes of the central and southern volcanic zones of the Andes, with high mercury levels, particularly in Chile and Argentina. However, emission data is geographically sparse, showing highly variable mercury concentrations. Next, please. In New Zealand, geothermal emissions have been shown to be on par with anthropogenic emissions, with atmospheric mercury concentrations high at fault and geothermal sites. In Australia, substrates exceed many times emissions from background sites. Well, from all we have reviewed, we can conclude that the results obtained of the review highlight the need of more research to enhance the coverage of mercury measurements in volcanic regions, particularly in Papua New Guinea and Indonesia. Also, it is necessary to investigate geogenic mercury emission fluxes to the atmosphere and their impact in terrestrial and aquatic ecosystems. Mercury studies are needed also in continental ice fields, for example, in Patagonia, in temperate volcanic regions affected by climate warming, because it's necessary to evaluate the impact of glacial melting on the mobilization of mercury locked in the ice. That's all. Thank you.
Thank you, Maria. So perhaps then I will turn to Jenny for the second paper.
Yeah, do you want to just keep sharing the slides the whole time, Isaku? Is that easier?
Yes, I think it's easier.
Okay, great. Well, thank you, Isaku, and thanks, Larissa and Maria, for the introduction to the first paper. We're going to turn now to the second paper on the anthropogenic perturbations, and Linwell and I will present that one. Title and author list are shown here. Go ahead onto the next slide, please, Isaku. So we use the same kind of framing as in the natural paper for the anthropogenic paper, and we really focused on 4 key differences between the 2 hemispheres in terms of anthropogenic perturbations to the Mercury cycle. The first area that we focused on was legacy Mercury and how different histories of Mercury, gold, and silver production relate to legacy emissions. Next slide, please. So for those who aren't familiar, when we talk about legacy emissions, we're talking about past anthropogenic emissions and releases. So that can be anything in the distant past or the near past, things like historical gold and silver mining and production that have emitted or released mercury into the environment. That's then been deposited into short-term reservoirs like soils, vegetation, aquatic systems that can then be re-released into the present day environment. And so this is kind of a legacy of anthropogenic activities that is still having an impact today. This is tricky to understand because, of course, we don't have direct past measurements, especially from the more distant past. We weren't measuring mercury emissions or mercury releases or concentrations back during the mining booms. And so to understand the legacy mercury contribution, we have estimates that are based on either historical archives, which require a number of assumptions, or natural archives, which also require a number of assumptions. And so in both cases, there's a lot of uncertainty as we try to piece together what's happened in the past and how that's affecting things now. Next slide, please. So thinking first about the historical data, we know that mercury was used in historical gold and silver production, and in some past papers, there's been a lot of discussion about the use of mercury in gold and in particular silver and what that's meant for a sort of large pulse of emissions and releases in certain eras. However, current understanding shows that not all processes for gold and silver actually used mercury. There are different ways to extract it and different ways to refine it. And for silver, a majority of the mercury used was actually stored in a stable byproduct, solid calomel. Now, what happens to that calomel and how long that persists is still an open question. But what it means is that some of these previous assumptions about big pulses of mercury from these mining processes and hemispheric differences in the mining may not, in fact, be relevant for thinking about this legacy source, or may not be as big as they were predicted to be then. However, another term that also needs to be considered is the direct production of mercury itself and its use, so use in various things happening in the 1800s, for example. And that we know was from a few different sources was much higher in the Northern Hemisphere than in the Southern Hemisphere. And so this is kind of still an ongoing open question, but one of the areas where we really need further information is on looking more carefully at some of the historical data, and in particular things like trade records that can show us where these products were mined, where they were used, how they were traded, and what countries contributed. To the best of our knowledge at this point, we can say there's still a lot of uncertainty, but there's probably a higher legacy signal in the Northern Hemisphere than in the Southern Hemisphere because of this difference in mercury production and use. Next slide, please. Turning to the natural data side of this question, the natural data really come from typically sediment cores, and these can be taken from lakes or peat bogs. And what these record is the historic deposition. So we know that what goes up must come down, and what's been emitted to the atmosphere typically is recorded in the deposition archives. But there are a number of uncertainties here as well, and things like local physical and ecological processes within, a lake basin, for example, impact what's recorded. A number of studies have shown that many emissions are deposited fairly locally, and so if a core is taken downwind of what was once a major mercury emitting region, we'll really be recording those local records rather than recording the kind of bigger picture hemispheric or global records. And finally, as with many things in the mercury world, there are more studies in the Northern Hemisphere than the Southern Hemisphere. And that's not just a question of how much data we have, but actually biases in different environments that have been sampled. Many of these sort of more limited studies in the Southern Hemisphere have been in regions that are strongly influenced by the ocean. And as Larissa spoke to earlier, there's a large source from the ocean. We don't have as many records from inland environments that can tell us whether these samples that we've got currently are representative. So there's a big challenge in trying to interpret cores as a proxy for global or hemispheric legacy mercury. That being said, there are some useful studies of this to date, and there are some different findings that have come out of these. A number of different studies have shown that if we look at change since about 1850, both the Northern Hemisphere and the Southern Hemisphere have shown increases in the amount of mercury deposited of order 3 to 5-fold. And this would be, I guess, a little bit at odds with some of what we're seeing with the historical data of potentially a larger legacy source in the Northern Hemisphere. However, a more recent study, which has a number of uncertainties of its own, showed some really different patterns with an all-time enrichment, so going way back further than 1850, an all-time enrichment of about a factor of 4 in the Southern Hemisphere. Oh, sorry, there's a typo on that slide. 4 in the Southern Hemisphere versus 16 in the Northern Hemisphere. And that would imply a much larger enrichment over time in the Northern Hemisphere as well. So there are still ongoing uncertainties, but one thing that we know we need is better and more diverse records of the historic deposition in the Southern Hemisphere. Next slide, please. The second topic that we tackled in this anthropogenic paper was around fire and deforestation, and the higher fire rates and the higher deforestation rates that happen in the Southern Hemisphere, and what that implies for mercury emissions as well as the mercury sink to vegetation. Next slide, please. So we know from various different sources that most of the fires globally are in the Southern Hemisphere and tropics, and that depends, it's sort of the same story depending on how you count, whether that's the area burned, the amount of fuel that's burned, the carbon that's emitted. Southern Hemisphere and tropics are very large fire sources. Part of that is due to a lot of savanna ecosystems. These burn really frequently, so they have a rapid return interval, and there's fire all the time, which may impact the amount of mercury that's stored in that vegetation. When we talk about fire and we talk about fire impacts, it's quite difficult to separate out what's natural and anthropogenic, both because the vegetation and soils that are burning will have some of that legacy contribution, but also because there are questions about what even counts as anthropogenic, how is the fire started, how does it propagate? So in this paper, we've combined the natural and anthropogenic contributions to talk about the fire source generally. And one thing we do know is that there are hemispheric differences in fire that are natural, but there are also hemispheric differences that are partly economic and cultural. And there tends to be a much larger deforestation fires, for example, in the Southern Hemisphere and tropics. In developing economies, which are more prevalent in the Southern Hemisphere, there tends to be more use of fire for a variety of purposes that tend to have been industrialized elsewhere, such as residential heating, use of charcoal, domestic cooking. And there tends to be less funding available for management of wildfire. So all of this leads to a kind of broader fire emissions happening in the Southern Hemisphere. Next slide, please. What this means for mercury, so we first looked at the emissions of mercury from the fire, so how much mercury is being emitted to the atmosphere. And one thing that is quite consistent between different studies is that tropical fires dominate. But when we turn to looking at some of the regional signatures, which is what's shown on the plot on the left, there are really large differences between different studies in terms of how much mercury they estimate is being emitted to the atmosphere due to fire. And each of those different bars, different colored bars, is a different study or a different estimate. One of the biggest uncertainties here is understanding how much mercury is emitted when a fire burns, and this is something referred to as the emission factor. It basically says if you have a specific amount of fuel that burns, how much of that will be emitted as mercury. And part of the challenge here, again, is that there aren't very many measurements, and there are a couple of different ways that you can measure this mercury emission factor. One way is to look at the soils and the vegetation and look at them before a fire and after a fire and see how much the mercury load has changed. Another way is to look at what's in the smoke and relate how much mercury is in the smoke to other species that we understand the emission rates for. The problem is that the few measurements that we have show some really different values between these two different methods, and there really aren't enough measurements for us to be particularly certain about what's happening. In addition to that, there are a number of assumptions that go into this, and one of the assumptions is that, for example, in equatorial Asia, where there are large amounts of peat cover, the emission factors are very high from the peat, and that is largely based on measurements from peat in the boreal regions of the Northern Hemisphere. As far as we could find, there actually have been no measurements of peat fires in equatorial Asia, or really of any fires in equatorial Asia. So there's a real uncertainty in how much mercury is being emitted. And if we couple that with some of the things that Larissa talked about earlier about the variability in soils and the variability in the vegetation uptake, we know that there are likely to be differences in the amount of mercury that's in that ecosystem available to burn in these Southern Hemisphere environments, and certainly relative to the Northern Hemisphere where most of our measurements are based. So in terms of future directions for understanding the fire source of mercury, we really need to understand a little bit better what's actually coming out of the vegetation and the ecosystems that do burn in the Southern Hemisphere and how much mercury is there to begin with. Next slide, please. The second piece of this that we looked at was deforestation. And there are a number of mercury-relevant impacts of deforestation. There are the direct emissions from fire, as fire is often used as a way to deforest, which are related to what I just talked about. But there's also a remobilization of mercury that's currently stored in soils to both the air and the water. And research in some deforested areas of the Amazon, for example, has shown that there's a sort of, rather than an immediate impact like we have with the emissions to air from the burning itself, the soils that are exposed will continue to emit extra mercury to the air over a period of weeks to months. There's also erosion and mobilization of that mercury from the soils into water bodies. And of course, this then changes the cycling pattern. Another piece of this is the loss of vegetation. So obviously deforestation is the removal of vegetation. And again, if we think about what Larissa was talking about earlier, if we remove that vegetation, we remove that sink from the atmosphere. And this leads to increased concentrations in the atmosphere. And this is what's illustrated conceptually in the figure on the right. So the bars across the bottom are from the FAO Global Forest Resources Assessment. And these show how much forest area has changed in different continental regions over the past few decades. And on the left are most of the North American continents where there tends to have been net forest growth. And on the right, we have Africa, South America, and Oceania, where there has been net forest removal or deforestation, particularly in Africa and in South America. What that means, looking at the green arrows, is that the amount of vegetation uptake of mercury in these regions has decreased, and therefore, looking at the blue arrows, the amount of mercury that is remaining in the atmosphere has increased. And this can be rather a large source, and it's particularly an important question in areas like the Amazon, where, as we saw earlier, there is a large amount of mercury in the soils and in the vegetation. And this is an area that has had really strong deforestation. And so this is a potentially very large area of concern when thinking about how we regulate and consider mercury cycling. It also means we need to rethink a little bit some of the ways that, as a scientific community, we sometimes talk about fire impacts, because we tend to think about these direct emissions only. But we really need to consider, when we're looking at, for example, modeling studies, how these effects continue over periods of time and how the effect of remobilization and the loss of vegetation actually contribute back to this question of how much impact the fire or the deforestation has had. With that, I think we'll pass over to Lin-Will on the next slide.
Okay, thanks, Jenny. So the third topic, or the third sector that we focused on in the second paper of the Southern Hemisphere, was artisanal and small-scale gold mining. And I think recently we have seen that the contribution from the ASGM sector is much more significant than what we have predicted in past years, especially if you look at the GMAs. Next slide, Isago. So what we saw when we looked at all the papers and all the data is that the ASGM sector is really big. There's about 100 million people that is involved within the sector, and it contributes about 1/5 of the global mercury production. As commonly known, that the mercury is used to form the amalgam, and this is the method that is mostly used by these ASGM miners. The very downside of this method is that it generates a lot of tailings that is highly contaminated with mercury, and depending on the location of these ASGM sites, some are very secluded high up in mountains or in forest. Some are very close to rivers, so these tailings goes into the rivers, and depending on how close these rivers are to people living by, or even the ocean, this mercury is then transported and released into this environment as well. From an atmospheric point of view, we know that mercury, when these amalgams heated to recover the gold, this is the main pathway of mercury into the atmosphere when heat is applied. In terms of in terms of the different processes that is also used by these miners, is that they know that once they have added the mercury, that not all the gold has been extracted. So in some cases, in some areas, they even add cyanide to recover as much as possible from the ore that they have, to recover as much as possible gold from the ore that they have. And I think this in itself even create what I call a deadly concoction, as we got now mercury as well as cyanide that is now part of the whole process. Next slide. In terms of some stats for the Southern Hemisphere, right, we know about 70% of the global use of mercury is in ASGM occurs in the Southern Hemisphere and in the tropics, and mostly in Central and South America, then Indonesia, and then in Africa. In terms of the amount that's used per year, what we found is that for South America, in terms of country-wise, it's very high in Peru, about 324 tons per year, and in Indonesia as well. From the data from the national action plans that has been submitted by countries, on average, what we found in this report is that for 1.5 grams of mercury, you get a gram, 1 gram of gold is produced. If you're looking at it from a chemical equilibrium point of view, the AGM miners definitely overcompensate for this, and they use too much mercury for the amount of gold that they want to extract at the end of the day, which of course is again detrimental for the environment. Next slide. If we are looking at the total amount of mercury emissions to the atmosphere from the ASGM sector, it's roughly estimated by about 1,660 tons per year. This number could be overestimated or underestimated, but this is the rough estimates according to what we were able to find from GMAs and AMAP and some of the literature that is available. For in the tropics, especially, pardon, ASGM is the dominant source of mercury emissions to the air. And for the sub-Saharan region, it's about 70%. And for South America, we're looking at about 83%. And as you can see on the graph, especially on the right-hand side of the graph, the region that is covered in the south, most of the emissions is basically because of ASGM that's been released to the atmosphere. Next slide. So there has been many studies done, especially in South America, when it comes to ASGM, but there's definitely an imbalance in terms of the data that is available, especially for Africa. If you look at Indonesia, that we estimate about almost 450 tons per year. The amount of publication that is related to that is just under 80. And I mean, we can contribute this to several factors. As we've seen that ASGM is mostly seen as a challenge or problem in the Southern Hemisphere. So most of the researchers that focus on research involving ASGM is mostly located within the Southern Hemisphere. As mentioned earlier, if you look at mercury research globally, most of the researchers are definitely found within the Northern Hemisphere. But I think there's definitely a shift in that, is that we are definitely seeing that more researchers from the Northern Hemisphere is collaborating and also working on ASGM project with researchers in the Southern Hemisphere. So we are hopeful that this graph will definitely change in the next few years, as more publications will definitely come out in terms of the issues and the challenges that is associated with ASGM. But in terms of the estimated usage versus the available data, there is definitely an imbalance, and we definitely need more research to take place specifically on ASGM within the Southern Hemisphere. Next slide. So the fourth aspect that we focused on in this paper was industrial sources. Next slide, Isako. And specifically, coal combustion was one of the key areas that we focused on. And then we've also found that the largest source of industrial emission in the southern hemisphere comes from coal combustion, compared to the northern hemisphere, with all the air quality regulations and air quality improvements and guidelines that have been implemented in the northern hemisphere over the last few years. We've definitely seen a decline across the northern hemisphere in terms of emissions from industrial sources. For the southern hemisphere, the picture is a bit different, where we have seen increase in industrial emissions over the last few years. The challenge also, especially in the southern hemisphere, as most of you know, that air measurements, there's not a lot of there's not a lot of stations or monitoring station, ground-based stations available or doing continuous monitoring within the southern hemisphere. So this in itself is also hampering that we can really see what is going on in the atmosphere. Next slide. You went back, Esaku. Yeah. So if we are looking at coal, specifically coal, then we found that South Africa is the fifth largest consumer of coal in the world. Currently, South Africa depends about 90% of our electricity in South Africa is generated by coal. The challenge that we are facing currently now is that most of the power plants still operational within South Africa is more than 35 or even 40 years old. So from a technology point of view, you can't do too much upgrades because the power plants are so old. And so the abatement technologies that is currently in place in some of these power plants are not so effective compared to the wet flue gas desulfurization that some of the newer power plants are having. In terms of the mercury content in coal, we've also found that specifically the coal in South Africa has got a very high mercury content. It comes on to around 0.27 micrograms per kilogram. And on average per year, if you look at it, we emit between 70 and 40 tons per year from coal, mercury emissions to coal. Compared to Indonesia and Australia, next slide, please. The situation is quite a bit different. The grade of coal or the mercury content in the coal used in Australia and Indonesia has got a lot lower mercury content, and in itself, on average between these two countries, we are looking at overall coal emissions or mercury emission from coal between 3 to 4 tons. Yeah, I don't know. Did something happen now?
You're back now.
Okay, yeah, okay. So yeah, as I was saying, this is mainly due to the mercury content in the coal found in Australia and Indonesia that is of a much lower percentage compared to the mercury in coal that we are finding here in South Africa. Next slide. I think I just had a glitch or something here. Next slide, Isako.
Isaku, can you hear us? Can you hear us, Aku? We've lost Isaku's sound and we've lost Lin Will simultaneously.
Sorry, do you hear me?
Yes, you're back.
Oh, sorry. Sorry. Yeah, but both the emails and
But
my,
now Lin Will is gone.
yeah. So I think he's going to reconnect.
I'm happy to step in and
Yeah,
continue the last parts if you'd like.
Yes, please.
All right, can you jump to the next slide, please? All right, so somebody let me know if Linwell gets back, but the last piece of the industrial sources that we really looked at was the non-ferrous metals production. And these are important sources of mercury, both to water and air, as well as to emission to air. Water and soil, as well as emission to air. And this happens during various phases of the processing, largely, not so much the mining itself. There are some really, really big uncertainties in this process, and one of them is understanding what's actually in the ore, because that varies dramatically from place to place. There are also questions around the pollution control and storage. So what happens actually to the mercury in the ore that is not, for example, roasted or smelted or processed? How is it stored as waste? As well as the fact that there can be a disconnect between where the ore is mined and where the processing actually happens. So things can be exported as raw ore. And so what's associated with one country or even region can be really variable. And a key point for this is that unlike many of the other sources that are going down over time, demand is really high for metals, and there are projections that this sector will continue to grow rapidly in the future and could in fact become a major contributor, especially in the Southern Hemisphere. Linwell, I can see you're back on.
Yeah, I was going to say he's back.
Can you hear us, Linwell? Can't see or hear him yet. Why don't we jump to the next slide? I'll keep going for the moment.
Yeah.
So one of the things that we did, and this relies on estimates from the Global Mercury Assessment, which have all of those uncertainties involved that I just mentioned. But we looked at specifically at the Southern Hemisphere continents and the countries that have large sources from non-ferrous metal production to see where this non-ferrous metal source is important. And this is shown in the plot on the left, which is emissions to air associated with this production for each country, and it's colored by the different metals that are processed in those areas. It mapped pretty closely to some extent to where the large deposits of these metals are, as you'd expect. But there are really big variations here. And it's a particular concern in South America, where it's responsible for a very large amount of emissions, actually, and more than 50% of the non-ASGM total. And in some places where there's not a lot of ASGM, I think Chile might be one of those examples off the top of my head, it can actually be the dominant source of emissions to the atmosphere in that region. Gold and copper were the most important, followed by zinc to a large extent, and in some places, a few other sources. And I believe that's the last slide for this section. Next slide, please. Great. So I'll hand over to Rob to provide some final remarks and conclusions about both papers.
Hello, everyone. Hopefully you can hear me. So these are two figures from the one from each paper, which tried to summarize the factors that have just been talked about by all the speakers. And so I just want to try and summarize and bring things together before we go to the question and answer session. So, right, the two papers talked about natural and anthropogenic sources, and you can see actually that those things are not always easily separated from each other, and processes that have an anthropogenic component can actually release mercury that is naturally in the system. The biggest difference between the southern hemisphere and the northern hemisphere is the distribution of land, where it is, whether it's in tropical or temperate environments, and the amount of ocean area, which is larger in the southern hemisphere, right? If we talk about the southern hemisphere versus the northern hemisphere, the tropics themselves are actually a unique environment, and so it's hard to separate them. The tropics have both the northern and southern hemisphere as part of them, right? So that it was one of the difficulties we had in trying to bring this all together. The differences in vegetation between the northern hemisphere and the southern hemisphere is a big component, right, in terms of mercury uptake from the atmosphere by the vegetation, and also more biomass burning and deforestation in the southern hemisphere is having a large impact on this release of mercury back to the atmosphere, and the lack of uptake because of the biomass burning and deforestation, right? While the southern hemisphere and the tropics historically have had less mercury emissions to the atmosphere, this has definitely changed with ASGM activity. The ASGM activity is mostly confined to the tropics, and as I think Jenny said, 70% of the ASGM activity is in the southern hemisphere and tropics. So this is a big part of ongoing sources that are very concentrated in this part of the world. As was mentioned, methylation seems to be more happen more effectively in tropical environments and in South America. That was talked about. And again, the tropics are very important as sources of inputs to the ocean from rivers. And again, while in the southern hemisphere, river inputs are much smaller than they are in the northern hemisphere. Jenny talked about industrial sources, coal burning, Jenny and Linwell, coal burning being a very important source in South Africa, and other non-ferrous metal and other production in other parts of the world, other parts of the southern hemisphere being important sources to the atmosphere. So hopefully my brief comments here have summarized things, and I see we have a lot of questions, so perhaps it would be good to go to the questions, and I'll go through them in the order that they were posted. All right, so the first question was from Isaku, I think, and he said, interesting to learn that modeling says the Southern Ocean and the Southern Hemisphere is a net sink. He points out that as mercury concentrations are higher in the Northern Hemisphere, you should think that the Northern Hemisphere is a net sink, and there'd be a source in the Southern Hemisphere. I guess I could potentially try and answer this question, and then other people could join in after that. Yeah, the difference between the modeling and the measurements, going out on one cruise or going out on a few cruises is a very little amount of data compared to, that we use to do the estimates from our actual measurements, and the modeling, it has a different component. I think it's not saying that the Southern Hemisphere is a net sink for the oceans, a net sink in the Southern Hemisphere. The oceans are also a net sink in the Northern Hemisphere, I think, based on the modeling that was shown in that paper that was talked about. That's my recollection. Does anyone else want to say something about that?
Yeah, it's
in general. Go ahead, Larissa.
No, go for it.
Oh, I was just gonna, in general, we've been saying this in the Southern Hemisphere on understanding we observe anywhere where we have a sort of full bag of what I mean. We have some where we don't know the ocean as well as the other. They have trouble following what's happening in other environments in the as well. So to the oceans too.
Yeah, I think for the paper one, that was one of the most uncertain that we have to describe, because there's really few data available. And interestingly, every time that we present the work, there are questions about the ocean. So I believe it's something that everyone is waiting to hear more about it.
Yeah, I mean, and we've been talking about this in other activities that I've been involved in. I mean, one of the difficulties, right, is that we make measurements of elemental mercury in the surface ocean and use that to estimate evasion to the atmosphere. And there's some assumptions that go into making those estimates, and it's very hard to actually measure whether or not. And there's a lot of questions at the moment about the potential for elemental mercury being taken up by the ocean from the atmosphere. And that is a large uncertainty in the estimations that are made. All right, the next question was industrial sources of mercury in the Southern Hemisphere. Have you considered oil and gas production as a source of mercury? And then the second part was ferrous metal production. I think this question was posted before the section on the ferrous metal production was presented, and the increased use of recycled metals that have mercury contamination. Linwell? Or Jenny?
Yeah, I'm not sure if Linwell's still having some issues because I can't see or hear him. But Linwell, if you want to jump in at any time, feel free. We sort of picked areas of focus for this based on what the estimates showed were the largest sources because the paper was so broad as it was. So we delved into the coal combustion and the non-ferrous metal production because those are predicted to be the largest sources in these environments. And we didn't really dig into the oil and gas production, although I know there's a lot of ongoing work on that at the moment and expect that some of those estimates might change in future. And our estimates came directly for the metals production side of it. They came directly from what is in the Global Mercury Assessment and what was in the UNEP Global Mercury Partnership report on non-ferrous metal production. I don't recall whether or not they considered the recycling of sort of contaminated metals from the past, so I'm afraid I can't answer that part of it.
Right. So the next question, what are some of the main factors between such discrepancy in mercury emissions research data in the Northern versus Southern Hemisphere? Is there anything that can be done to help increase mercury emissions research in the Southern Hemisphere? More funding, I guess. It's certainly, we need to have many more long-term monitoring sites, I think, in the Southern Hemisphere. That is certainly one of the biggest problems at the moment, right? Is that we have a lot of long-term monitoring sites in North America and in Europe, and very few in the Southern Hemisphere.
Yeah, it's a shame that Linwell's not able to talk because I know he could talk a little bit to some of the work that's being done to try to use passive samplers to broaden the scope of where we have measurements, at least in the air. That's work that I think there are a number of different groups that are starting to work on and trying to get a broader global picture, which is really exciting. I'm sure Larissa might have some thoughts on the why there's the discrepancy between Northern and Southern Hemisphere. But I think one of the things that really came out of this for us when we were writing these papers is how different these environments are. And I think that provides a kind of useful framework for why we would invest in making measurements in some of these different environments, because it's not necessarily clear that what happens in, a forest in North America is going to give us the right kind of answers for what happens in a forest in Central Africa. So I think hopefully this helps a little bit, but I think Rob's right. It comes down to funding and being able to support these kinds of measurements. But I don't know if Larissa or Maria would like to talk about other reasons for these discrepancies.
I think one reason actually I discussed with Maria while we were writing the paper is the number of remote areas that we have in the Southern Hemisphere. And especially if you compare with Europe, like wherever you want to go to Europe, you probably have a train that takes you there. it's quite well served and accessible. While, you know, like if you want to go to Papua New Guinea, for example, when I went to Papua New Guinea, it was really difficult, you know, to move inside the country. It was, you know, dangerous at certain parts. And so we have quite a lot of this problem in the Southern Hemisphere of having remote areas, which it's hard to take equipment to those locations, and also it's hard to get permits to work there, and it's a combination of access problems on top of all that Jane already said, and Rob.
Linwell, you're back.
Yeah, welcome. All right,
You're
so
on mute. Did you want to add anything? You're on mute at the moment, though.
I think the only part I heard fairly was in terms of the monitoring. So yeah, I think we've been tried with the help of Sandy Stefan, just for Africa, if I can focus on Africa for a moment, that we've been trying to expand the monitoring capabilities on the continent through the Global Mercury Passive Network, which is coordinated by Environment and Climate Change Canada. And so we've been able to start new stations, say in Ghana, Botswana, Tanzania, Namibia, Kenya, Nigeria. And just for interesting fact, we've received the first results from a site from the site in Ghana, which is close to an ASGM site. And the average mercury concentration that we found there was 34 nanograms per cubic meters, close to an ASGM site. So that is extremely I don't know how else to put it here, but that is the type of concentrations that we are looking at. I mean, for the first time we can actually put a number to it, which is good. Before we were only speculating of what it could be, but at least now we've got some evidence or some real values. And I think if we can expand it even more through something as simple as a passive sampler, I think that in itself will already help us to predict, or even when it comes to modeling, to be a bit more accurate. There's a lot of uncertainty, especially in the Southern Hemisphere, because there's really no data in a large population or large part of Africa and in South America. But I think through something as simple as that, we will definitely be trying to close the gap there first. Yeah, but at least we can say we've got something that we have proof of it scientifically now, that this is the type of concentration that we are dealing with. Yeah, compared to what they found in some of the other areas. They also have a site in Indonesia, and the highest concentration there was about 8 nanograms per cubic meter. So there's definitely a large difference between that. Yeah, but yeah, it's extremely higher. I just wanted to add to that.
yeah, and there's a comment in the chat that there are also measurements being made in the Ivory Coast, which is great to hear.
Yeah, so now Julian mentioned that.
Yeah. So there was a question that saying, are you familiar with some of the technologies that have been used to measure mercury emissions in the Southern Hemisphere? I guess this is talking about anthropogenic emissions. I don't know who can answer that question.
I can talk a little bit to it. I guess when it comes to emissions, often they have to be estimated. There are some measurements from, for example, you can make a measurement in a plume or at a site, but that then has to typically be extrapolated up to a full time period and how that applies to other places. A lot of times we use what we call bottom-up estimates, where we look at things like, for example, if you're looking at emission estimates from coal-fired power plants, you'd be looking at some of these things Lynn talked about. So how much coal is actually burned at a given power plant? What do we assume the mercury content in that coal is? What are the efficiencies of the capture technology? So how much of the mercury that's emitted is actually being captured before being released out into the atmosphere? And so combining all of these different data together, the emission factors, the activity data, the pollution control, to make an estimate for sort of each individual power station, for example, where that's based, what fraction of that is in elemental mercury versus reactive mercury, how high that's emitted, and all of that kind of goes into what we call this bottom-up estimate, and you can do that for all of the different sources. So it does mean that there are a number of uncertainties in the process, and it also means that to have kind of these global estimates, you have to make some consistent assumptions about how you're going to treat this, and that's probably why I mean, it's an ongoing question, I think, in the Mercury science and policy community about the best assumptions to make and the best way to do it. But it does mean that we don't always have kind of real-time updated estimates of emissions from everywhere. If the question is more about measurement, we measure, at least on the air side, and I'm not a measurement person, but we make different kinds of measurements of the concentration and use that along with some data analysis processes to get some ideas of where we think that's coming from, and that can give us a sense of how important different sources are, although it doesn't necessarily always give us a quantitative estimate of the amount of mercury. Hopefully that sort of answers the question.
Yeah. Yeah, so I mean, I guess, Linwell, in terms of emissions from like power plants in South Africa, have those been made? Have they been measurements in the of the flue gas or anything like that?
Hey, Rob, not to my knowledge. I know that, for instance, for Sasol, they do have, and I think for Eskom as well, they do have now in each of the plants, they have a type what they call a master site where they monitor all the air qualities, all the criteria for pollutants, in terms of air quality. I mean, obviously, we don't have access to that data, but at least there's some type of monitoring going on. In terms of my network, we have a station just outside of Witbank, where we monitor also air quality as well as mercury. And so we are definitely seeing, in terms of background concentration, we averaging between 2 and 4 nanograms per cubic meter. So that is the trend that's ongoing currently there. Yeah. But I mean, the actual raw data closer to the sites, we don't have any data for that. But at least there's a air quality station close by to some of the power station that we can at least monitor or have an idea of what is actually going on in the atmosphere.
Okay. I guess we should move on to, there's a question about the prediction that deforestation would lead to an increase in mercury concentration has not been confirmed by data, right? So I guess the question is, these predictions are based on modeling rather than based on measurement.
Yeah, it's a mix of both. So there have been some measurements, and we don't have Anne today, who is one of our co-authors, but she's led some of these studies. So there have been some measurements in the Amazon where they've looked at sites before and after the deforestation, and they've been able to look at how, for example, the emissions from the soils are changing over that period of time. In a given location, it's going to be a relatively small signal, I think. So measuring, having a monitoring site that's going to be hundreds of kilometers downwind, we might not be able to get those individual impacts. But then there have been a number of modeling studies that have approached this in a few different ways and also see quite a sizable impact from that deforestation impact on the air concentrations.
Okay. Yep. Excellent. So there was a question about what is the greatest hindrance to measuring mercury in the volcanic regions? I guess that's in South America, right? I guess, is it?
So, yeah. Can you repeat, Rob, please?
Sorry?
If you can repeat what you say.
It says, what is the greatest hindrance to measuring mercury in the volcanic regions? I mean, the lack of, is there a lack of measurements, and why is that? Or
Oh, I think it's the lack of funding. There is, for example, in South America, the only monitoring station was established by the GMOS program, and it is located in a volcanic region in in the southern volcanic zones of the Andes, and it stopped operating in 2019 because of the lack of funding, and the equipment is there, and we have a master station. We are able to measure gaseous elemental mercury and also the speciated mercury, but we don't have the budget to keep the station running. So we keep looking for funding because this is an important station which is influenced by volcanic sources and also by the oceanic emissions from the Pacific.
Okay. Yeah. There was a comment by Dominic Belli saying that it would be talking about the recent eruption in 2021 in the DRC. I didn't know about this. Any idea? Right. Thanks to the presentation dealing with emissions generally by volcanoes. It would be great to have an idea of the recent volcanic eruption in 2021 in the eastern part of the DRC. He also says emphasis will be put on both anthropogenic caused by ASGM in this part and natural emissions from geogenic sources. Thanks for the call for additional research to support Mercury science. Thank you, Dominic. I guess there was a question, a follow-up question from Arilen about concerns about using different passive samplers and how well they have been intercalibrated. And Linwell, do you know anything about this?
Yeah, so I think it was in 2019 or 2020, there was a paper published where they compared the 3 passive samplers that's currently available. If you're looking at it from a commercial point of view, only the MERPAS is currently available, which you can buy from the shelf. The other 2, the one was developed by Nicola's group in Italy, that was compared to that. And also, I think the other passive sampler is the one from Sweden that was developed by IVL. Yeah. So they did a nice comparison study in different environments. But if I can remember, I think the MERPAS performed quite well compared to the other 2. I think it was the MERPAS and the one from Italy that was very close to one another. But because the MERPAS is the only one that you can buy from the shelf, that is mostly being used. And you can also see some few groups have been able to put out some publications where they have used the MERPAS in terms of sampling. Yeah. So I think there's definitely an opportunity to do some new research work in terms of an active material that you can use to as a passive sampler. I think the more competition is out there, the better. And I think in some areas, one of the passives will perform better, say where it's cold or it's snowy, and then say more in the humid conditions, some of the other passive samplers will maybe even perform better. So I think there's still a lot of research that we can do in terms of that, but at least there's a benchmark which we can work from on there. So I think that paper was published in 2019, if I'm not mistaken, and it's quite a good read to see how they've compared it. Yeah.
And have the passive samplers been compared with actual, a TechRAN instrument or something like that?
Yeah, Jenny, I think you can add on that.
Yeah, no, there's another paper where they've done that in quite a few environments, and that, unusually, I suppose, includes a number of Southern Hemisphere environments, at least a few different sites in Australia. So I think that was with the MERPAS, or the precursor to the MERPAS as well. But there are definitely, I think, there are still some uncertainties in the passive samplers, and they're not a panacea, but certainly for giving us the sense of those spatial patterns and a number like you've mentioned, Linwell, of 34 nanograms per meter cubed, I think we can comfortably say with any technique that's going to be a lot higher than what we see in the the background sites.
Yeah. So there was a question, can you share the name of the paper on the 3 passive samplers that you referenced? So Linwell, could you?
I think it's a paper by David was the first author, if I'm not mistaken, or somebody from Italy. what is that lady's name? McLagan, yeah. There is
David,
definitely.
David
Masone
McCluggett. Oh,
Mm,
okay.
yeah.
All right. So I think that's the end of the. Here it is. Someone has posted it. Thank you.
A new one, but that's also a very useful paper.
Okay. Another reading suggestion. Great. We got homework. All right. That's the questions. Are there any other questions from anyone?
That's all, yeah.
We're getting some papers listed. Great. Osako, I'll hand back to you.
Thank you, Rob, and thank you all. Thank you to all the presenters. I think this session was a very strong reminder that although we have been saying and we have been hearing that the mercury is a global pollutant, we really need the data and information from the southern hemisphere to come up with a really global solution to the mercury pollution problem. And I'd like to let all the participants know that the Minamata Convention is working on the effectiveness evaluation based, trying to bridge the scientific data and policy making. And I'm putting the link to the chat. And the open-ended scientific group met last month, and then the group agreed that let's start with what we have, and let's start with what we have from the governmental data and also from the scientific literature, and then the identify gaps and proposed the need for bridging these gaps to the policymakers. So I think if any of you are interested in what the scientific group is doing, please visit the website, and you will be you may be able to participate through the rosters nominated by parties and stakeholders. So thank you very much. I think from the Minamata Convention point of view, this session was very helpful. Lynn, did you want to say something from the ICMGP perspective?
I think all I can do is just save the date, 21 or 26 of July. It's going to be big. That's all I'm going to say. Watch the space. As I've mentioned, we'll definitely be coming out with some announcements in the next few weeks, and also maybe just a video, just as a teaser to what will be awaiting everybody when they come to Cape Town next year. Yeah. Thanks, Isaku.
Thank you, Lynn. We really look forward to the first African the meeting in Africa of the ICMGP, first real meeting.
Yeah.
Thank you very much, and I wish you pleasant rest of the day. And thank you very much. Goodbye.
Thank you. Bye-bye.
Bye.